All right, this is section 2.5 out of your Math 120 textbook. It's about transforming functions and reshaping those with how we change the formula. So what we're going to do here is we're going to be talking about vertical shifts. So the example here you see is that if I subtract a number from the outside, we're basically going to shift all the y coordinates down 2. So the y coordinates I see, there's 5 of them. All of these y coordinates, we're going to take away 2. So let's see here. 0 goes to -2, 4 goes to 2, 0 goes to -2, -2 goes to -4. And if I have a vertical shift down, you basically have just the same shape, but you have it shifted down 2 units. So that is a vertical shift down 2 units. What happens if we add a number to the outside? We see that's a vertical shift up, so I'm adding 3 to every single ordered pair to the y coordinate, that is. And what I have now is a vertical shift up 3 units, and that is my new function. Horizontal shifts, we say they lie to you. And what that means here is if I have this particular function, f of x minus 3, it's actually going to shift it right. I'm going to add 3 to every x coordinate. So that's the -4, the -2. So let's see, that's going to take it to -1. This goes to 1, and then that ordered pair goes to 3. So the left half of this graph is shifted to the right 3 units. Let's move over this to the 5, and this to the 7. And then I'll have that particular part of the graph. So that's a horizontal shift to the right. If I add a number, it's going to lie. It moves it to the left. So if I shift every ordered pair to the left 2 units, I will get this particular graph. All right, moving on to reflections. If you have a negative on the outside and you reflect it across the x-axis, what happens is all of the y coordinates change signs. So notice that your 0 y coordinates don't change, but this 4 becomes -4, and you have a reflection across the x-axis. See if I can do that a little better. So there is some symmetry there. There we go. And then this -2 becomes 2, and so that is a reflection across the x-axis. If we have a negative on the inside, we will reflect it across the y-axis. So basically what happens, all of your x coordinates change sign. Notice that your intercepts on the y-axis don't change, but this -4 becomes 4, and this -2 becomes 2. So reflection across the y gives me that shape, and then if I move this to the opposite side, I will have that on the other side. So there's a line of symmetry here. That line of symmetry is the y-axis. On the previous example, the line of symmetry is the x-axis. So those are 2 reflections. Let's do the vertical stretches. If you have a number on the outside, the idea here is that we're going to multiply all y coordinates by c. In this case, we'll multiply all the y coordinates by the 2. Notice your x-intercepts still don't change, but this 4 becomes 8. So if I make that 4 into an 8, I get a point way up here. So that's a vertical stretch by a factor of 2. This -2 becomes -4. So what I have now is it's not the same shape, it's vertically stretched. When I have a vertical shrink, I'm still going to do the same thing. I'm going to multiply all the y coordinates by the 1/2 in the example. So let's see, if I multiply the x coordinates, the 0s, they don't change, the x-intercepts. But this 4 becomes 2, and this -2 becomes -1. And this is a vertical shrink by a factor of 2. Horizontal stretches and shrinks. Let's see. Here I'm going to now divide the x coordinates by c. And that's going to happen for both of these cases. Notice when we have a 1/2 right here, that means I will divide all the x coordinates by 1/2. I will divide by 1/2. And let's notice that that's the same as multiplying by 2. I would rather multiply by 2 than divide by 1/2. This makes an easier computation. So if I multiply all the x coordinates by 2, this -4 becomes a -8. This -2 becomes a -4, and this 0 stays right here. So this is a horizontal stretch by a factor of 2. The right-hand side, let's see, 2 becomes 4, 4 becomes 8, and I have a horizontal stretch. Notice it's the same height. It doesn't change the height. It just horizontally pulls this apart from the y-axis. Now, for the horizontal shrink, I will still divide by what number is in front of x. So that means I will divide by 2. So let's see, this -4 becomes a -2, this -2 becomes a -1, and the 0 stays on 0. So notice I'm pushing this against the y-axis by a factor of 2. This 4 becomes a 2, this 2 becomes a 1, and I have a horizontal shrink by a factor of 2. Okay, let's graph a couple parent functions just to see how these transformations look on a graph. So the first thing we'll notice is the parent function. We'll call it p of x. The parent function is the square root of x. So if I square root 0, I'll get 0. Square root of 1 is 1, square root of 4 is 2. This is the parent function. What we'll recognize is a vertical stretch by a factor of 2. So going back to our notes, we will recognize that we will multiply. Let's see, we're multiplying the outside by a number. That's the vertical stretch right here. And we're going to multiply all the y-coordinates by 2 in this example. So let's see, 0 stays at 0, 1 goes to 2, and 2 goes to 4. So this is the graph of 2 square root of x. Let's compare that to the graph of 1/2 square root of x. So once again, I'll graph the parent function. It's going to be the one I just drew on the upper example. Now, if I multiply all of those y-coordinates by 1/2, let's see, 0 stays at 0, 1 goes to 1/2, and then 2 goes to 1. That is a vertical shrink. So if I would put that graph on the one above, what we have here is an example of both. We have a vertical stretch, and we have a vertical shrink. Let's look at horizontal stretches and shrinks. Once again, I'm using the square root function. Let's do that. Let's do that. It's called p of x for the parent function. Let's go square root of x, and we have 0, 0, 1, 1, 4, 2. So what we have on the first example, it's a horizontal shrink. We are dividing. Divide the x coordinates by 2. And sometimes it helps to write those ordered pairs. Let's do that for a couple of them. This is the point 1, 1, and this is the point 4, 2. So if I take each of those x coordinates and divide by 2, look what happens. This 1 becomes 1/2. This 4 becomes 2. The 0 stays at 0. So what I have here is a horizontal shrink. That's the square root of 2x. It looks like a vertical stretch, but really it's a horizontal shrink because we're pushing it to the y-axis. Let's go ahead and graph the second example. I'll put the parent function on first. That's going to be in blue. That's the square root of x. And once again, if I have this transformation, I'm going to divide the x coordinates by 1/2. An easier computation would be to multiply the x coordinates by 2. So once again, we'll take all the x coordinates times 2. That's going to be, stay at 0. This 1 becomes 2, and this 4 becomes 8. So it looks like a horizontal shrink, but it looks like a vertical shrink, but it's actually a horizontal stretch. All right, let's do one more example where we see 4 transformations in one function. Let's write these out first and recognize what we have. What we have first, let's look at these two guys. We have we're going to go right 3, and we're going to go up 1. We also have a 2 right there, which is a vertical stretch, and then the negative in front of the 2 is a reflection over the x-axis. There's a couple ways to do this. Let's do this. Let's first take care of the 2 and -2. So let's see, a vertical stretch of a parent function. I'll graph the parent function. We've done that several times now. And then I'm going to reflect this over the x-axis. So let's see, that's going to be in green. That's the reflection, so that's -square root of x. Now let's go ahead and multiply all the y-coordinates by 2. That's going to be the vertical stretch. So 0 stays on 0, -1 becomes -2, and -2 becomes -4. So that is -2 square root of x. And then with the blue, I'm going to take those 3 ordered pairs and move them right 3 and up 1. So right 3 and up 1. Right 3 and up 1. And then right 3 and up 1. So this would be the graph of the final transformation of the entire function.